Okay, so we're going to look at factoring or finding x through factoring. Okay, so we've got to the first question here, and you common factored out 2x squared, which is good. Okay, give me a minute. So we're looking for solving for x, and like we said, you had just solved by common factoring. And what we have now is we have two terms that multiply to 0 here. So because the two terms multiply to 0, that means either of them must be 0. So I'm actually going to jump to another page so we have a little more room here. We have 2x squared, and that's multiplied by 4x. What's going on there? Minus 15x plus 44. Minus 15x plus 44. Okay. That's all equal to 0. What we're going to do is split the equation, just like we had done before. We know in one case we have 2x is equal to 0. And in the other case, we have x to the power of 4 minus 15x plus 44. Oh, that's right. There we go. Is equal to 0. Okay. If we focus on the one on the left-hand side here, this one's pretty straightforward. We can divide both sides by 2. We're still going to end up with x squared equals 0. We square root both sides. X is going to be equal to 0. So one of the solutions to this is 0. But we have a whole nother set here. We have to go about figuring out. Now this one we can do some factoring with. Actually, sorry, this is to the power of 2. Okay, because it's to the power of 2, we can actually use a lot of our old factoring methods to still solve this. We can still use our factoring by decomposition. So if you recall, you're always looking for two numbers that are equal to a times c, which in this case, the a value is 1. So 1 times 44 is just 44. And those same two values need to add up to the b value, which happens to be negative 15 in this case. So we can go through factors. I'm going to tell you a factor I think is going to work really well. It's probably 4 and 11. In fact, if they're both negative, they'll both multiply to positive 44, and they'll both add to 15. So this is the tricky part here, what we're not quite used to. We have x to the power of 4 minus 15x to the power of 2 plus 44. Still all equal to 0. Sorry about the drag. Let's see if I can fix that. What we're going to do is we're going to decompose that center term, that b term. Oh, it's got worse. And that's going to be negative 4x squared and minus 11x squared. Same process as we've done before, x to the power of 4 plus 44 on the outside. We're still going to try to common factor. In this case, we can pull x squared out of the first two terms when we common factor by grouping. And out of the second two terms, we can take 11, actually. In fact, let's take negative 11 out. So we'll take negative 11 out of this. When we do the first term, we'll get x squared. We'll get, inside the brackets, still x squared minus 4. Okay. And in our second term, we get negative 11x squared minus 4 again is equal to 0. Finally, the last step. We know we're technically common factoring again, but let's just write it out. X squared minus 4 times x squared minus 11 is equal to 0. Well, that gives us, because it's equal to 0, we still have two terms. We're going to jump to the next page here. X squared, I think it was minus 4. Yep. Minus 4 and x squared minus 11 is equal to 0. Okay, when we split it, we get x squared minus 4 is equal to 0. X squared minus 11 is equal to 0. Just like we've done before, x squared, when we bring negative 4 over, we'll get positive 4. We square root both sides. We'll get x is equal to both positive and negative 2. And in this one, we're going to get x squared is equal to positive 11. We square root both sides. X is equal to both positive and negative root 11. So if we jump back 2 pages, just one actually, we had this as a solution, x is equal to 0, And then we came out with technically 4 more solutions. X equals 2, x equals -2, x equals negative root 11, and x equals positive root 11, and x equals 0. That's 5 different solutions. And if you remember, this wasn't our normal quadratic. This was originally to the power of 6. That power of 6 tells us that we can actually have many more solutions to a question. So this one had quite a few answers in our specific question.